Hi everyone. So I'm going to talk about Faust2smartkeyb, a tool to make mobile instruments focusing on scale transfer in the Faust programming language. So let me give you some background first about this work. First, making musical apps for mobile devices involves the use and mastery of various technologies, standards, programming languages, and techniques. So if you want to make apps, usually you need to know Java, C++, Objective-C, managing the tool chain to compile apps for your mobile phone is very complicated, and it really varies a lot from one platform to another. So there are a lot of issues around developing apps kind of in a universal way, and especially if you have to deal with audio, where you have to do a lot of low-level work, especially on Android. You know, like Java doesn't really work with real-time signal processing, so you need to use C++. You know, like so that's a lot of things to deal with, and this adds up to the variety of platforms and other associated tool standards and languages. So these problems have been already kind of addressed in the past by the Faust team at Gram, but also in the frame of other projects. Thinking of mobile C Sound, Pure Data also allows you to export things to Android or to iOS, you know, and now Juice has a pretty solid backend for Android and for iOS as well, you know, like so there are options when it comes to you know, write something once and not have to rewrite it many times when you're targeting Android or iOS applications. But on the Faust side, the first tools that were developed in this directions were Faust2 iOS and Faust2 Android, and I'm sure that most of you tried that at some point. So Faust2 iOS allows you to take a Faust program and export it to an iOS application. So the usual user interface elements that you have in Faust are exported to the application. So if you have sliders, buttons, knobs, checkboxes, groups, you know, all these things will be ported to your app and will eventually become the main interface of your application. A little bit after that, we developed Faust2 Android, and it's basically the same thing as Faust2 iOS. The interface is different, but the result is pretty much the same and is very similar. So one thing that we noticed, you know, is that the user interface elements that you have in Faust, the default one, are not necessarily well adapted to the use on mobile devices. You know, because if you're using your mobile device as a musical instrument, sliders, knobs, and all these stuff, you know, they're not the most practical thing to deal with. A lot of composers just use the accelerometer, you know, and that's one way to deal with the problem, you know, like, but just being able to use your touchscreen as a proper musical interface is also important. And this type of interface is not very good for this type of interaction. So, so the tool that I'm going to present here tries to partially solve this issue. Before I talk about it, I just want to talk very briefly about Faust2 API. Faust2 API is this thing that we implemented about 2 years ago. At first, it was only for iOS and Android. And what it was doing is that it allows you to export a Faust program to an API that you can use on iOS and Android. So it doesn't take care of the interface, but it will take care of all the low-level aspects of your audio applications. And about a year ago, we added support to all the other targets that Faust supports, thanks to Stefan. So now you can use Faust2 API to generate audio engines for most of the Faust architecture. So in other words, it makes the source code of your Faust program without having the interface. Anyway, so Faust2Smart Keyboard, which is the tool that I'm presenting here, is based on Faust2 API, so it's built on top of it. And I think the best way to describe it is to do a few demos, but this diagram here kind of summarizes the way it works. So the main feature of Faust2Smart Keyboard is that the default user interface of your Faust application is replaced by a custom one that can be defined through a metadata that is declared in the Faust code. So the interface of your application is based on the smart keyboard configuration that is declared in the Faust code, as opposed to the regular user interface elements that you have in Faust. It allows you to create polyphonic synthesizers. You can add audio effects at the end. You can read the paper to have more details about this. I don't want to go into too many details here, because we don't really have time for this. But basically, then it uses Faust2 API to generate the DSP engine, and then it uses a template Xcode or Android Studio project to finally generate the application. The application that you get builds its interface based on the smart keyboard user interface declaration, and then uses the API generated by Faust2 API to do voice allocation, add the audio effects, and all these things. It also supports raw OSC and raw MIDI, and then take those data and map them to the different parameters that you have in your Faust program. Basically the way it works for other Faust architectures. It is compatible with MIDI as well, so if you want to plug sensors to your mobile device using an Arduino or any kind of other microcontroller, you can also do that. And that was very important to us because we needed to have this type of feature for different workshops that we did. Eventually, it just wraps everything up into a Faust DSP engine, adds the interface on top, and then you get your app. It's basically just an Xcode or an Android Studio project. So I don't have a lot of slides, and I think the best way to describe the way this works, is just to look at some examples. So all these things are available already in the Faust distribution, and they've been available in the Faust distribution for quite some time already. So if you go on the Faust GitHub, and if you go in the examples folder, you'll find a smart keyboard folder with a lot of examples of this type of application. So here we're going to look at a very simple one, which is trumpet.dsp. And now we can see the Faust code, which corresponds to this. Maybe I can zoom in a little bit. Is that better? Yeah, that is better. So you see that at the beginning of the Faust code, you have a metadata which is declared, and this metadata allows you to specify the configuration of the smart keyboard interface. See that kind of uses a JSON description to do this. So the idea is that you have keywords and values associated to these keywords. So here we're creating a keyboard which has 5 keyboards in parallel. All the keyboards are monophonic because we defined the polyphony to be only one. It implements voice stealing, which means that when you press a new key, the key that you pressed steals the voice from the previous one, which is very, very important, if you want to implement like guitar keyboards or things like that, and you can configure all these things using the different keys that you have here. Then you can define the number of keys for each keyboard. You can define the base MIDI note for each keyboard. you can ask it to do pitch rounding, which means that your keyboards is always going to be in tune. For those of you who already implemented keyboards on mobile phones, you probably know that if you just use continuous data from your keyboard, it's probably going to be out of tune, because depending on where you're going to hit the key, like you might be off by like a few semitones or things like that. So pitch rounding basically always rounds the pitch to the nearest integer, unless you do vibrato or you do slides or things like that. I'm going to show you the result of this very soon. And there we go. So the result of this application, and I'm going to show that to you here on my phone, is basically this very simple app, which just looks like this. So you have 5 keyboards that are in parallel of each other, and we define the pitch for all of them, and they are mapped to the sound synthesizer, which is declared under the interface declaration. So it is polyphonic across keyboards, but you can do slides, and it's always in tune depending on what you do. And this app will work both on Android and iOS, which is kind of nice. Now, how do you map this to the sound synthesizer that you declared in Faust? So in this case, the sound synthesizer is very basic. It's just a sawtooth wave going through a low-pass filter. And the way the interface that we declared here gets mapped to the sound synthesizer is by declaring standard parameters. So here we declared the usual Faust freq, gain, and get parameters, and those get mapped to the different keys you have on the keyboard here. But you see also that we introduced a bend parameter, for example, and bend here allows you to do the continuous thing. So you still have to do the mapping between bend and freq just by yourself. So here we declared a freq parameter, which is basically just the freq parameter multiplied by bend. So you have to interfere directly with freq if you want to have the continuous pitch thing happening. And the reason why we're doing this, is because that's the way the MIDI standard works. The freq parameter is basically the MIDI key number, and the bend is just the pitch bend. So if you want to do bends, that's how you want to do this type of stuff. Then here we're retrieving the Y position of the finger inside the key, and we're mapping that to the cutoff frequency of the low-pass filter, so that way, if you do vibrato like this on the key on the Y-axis, it's going to modulate the frequency of the low-pass filter, and do like this very nice natural effect. Because I'm running a little bit out of time, I'm just going to skip to a different example. So with Smart Keyboard, you can implement interfaces that are keyboards, but you can also implement interfaces that have nothing to do with keyboards. And this example here, which is toy.dsp, is basically just a blank screen where you can control different things with one finger, use potentially 2 fingers to control different parameters, also use the accelerometers, so you are not limited to just keyboard interfaces. Anyway, this is kind of a very big topic, so I suggest you to check the documentation of faust2smartkeyb, or just have a look at those slides that are available online, or just shoot me an email. This is all in the Faust distribution, but I will now take questions. Thank you.
Thank you, Romain. Are there any questions? Yeah?
Thanks. Hey, that's really cool. So I see you've got 3D printing, and one of the things I was thinking on your website there or whatever, but I was wondering, are you automatically printing keyboards?
That's an error. Sorry, I've been going to a lot of conferences the past few days, and I reused the same template for my slides. And yeah, I guess I didn't update this link. So this talk has nothing to do with 3D printing, but that link here is the right one.
Right. I suppose, but my question really is that, so some of the things that we're working on is that you've got this little DSL embedded inside Faust now for building your keyboards, describing your smart. Have you thought about actually generating physical interfaces rather than just running on the phone or something like that?
You mean like 3D printing them, or?
Exactly, yeah. And then maybe then and then inkjetting a conductive surface on top, for example.
Yeah, well, actually, yeah, we did. I mean, well, if you go to my website, you'll see that I worked a lot actually on that kind of stuff. So we had this big project, where we make mobile phone augmentations that are 3D printed. So the whole idea is that you start from your mobile phone, and then you 3D print elements that go around the mobile phone, and that potentially interact with the DSP happening in your phone. So the whole idea is to create hybrid instruments, that are partly physical and partly virtual. And tomorrow I'm going to talk about something completely different, but which is related to what you're talking about here, which is a series of tools, like to do physical modeling in Faust. And as part of this project, one thing that really interested us, was to start from a 3D graphical representation of a physical object, like say a violin body or something like that, and then how do you integrate that to an application as a digital instrument, or 3D print it, and then just plug it to your phone, and so I'll talk more about this, but tomorrow. But yeah, we worked a lot on that kind of stuff actually, and there are. You can find this on my website here. Just get rid of the 3D printing modeling part, but just till they are mentioned. Yeah, sorry about this. I'll fix my slides. And all these slides are available online. It's just a website. So if you want to follow the links, that should be up to date. And without mistakes or not, you can probably do it. Robin?
Do you also target different sizes? Like you have an iPad with 10-inch or a small phone, and if you do a vibrato or like even the range of for sliding, can you customize that depending on the target?
Yeah, absolutely. Yeah. If you check the documentation, you'll see that there are about 30 configuration keys. I only talked about the most basic one here. And yeah, you can totally scale things to different types of screens, and if you want things to become more sensitive as the size of the screen increases, or vice versa, you can totally do it, of course. Yeah. One thing I didn't say, is that you can do like microtonal things. You don't have to necessarily use like basic keyboards. So if you want to implement like specific scales or temperaments or whatever, you can do it as well. And it's all built into the smart keyboard interface. So.
Does it work on your ThinkPad as well with a touch screen, or you don't have a touch screen on your ThinkPad?
My ThinkPad, no. It's I wish, but this one doesn't have it. I was too scared it was not going to work with my Linux, so I was like, yeah, no touch screen. But well, I guess it works for Albert, so yeah. But I don't know. I was a little bit skeptical, but no, yeah. Any other question? Well, if you have more questions, you can ask them later. I'll be here for the next 2 days. So. Thank you.
Thank you, Romain.